In this video, we will discuss applications of normal distribution. So we're going to look at applications of normal distribution. In the last section, we looked at standard normal distribution. The main difference between a standard normal distribution and a normal distribution is in a normal distribution, the mean doesn't have to be 0 and the standard deviation doesn't have to be 1. But in a standard normal distribution, the mean is 0 and the standard deviation is 1. So if we convert those to z-scores, that means the data values and the z-scores will be same for standard normal distribution, which is not the case for normal distribution. Okay, so we have a normally distributed random variable whose mean is not 0 and the standard deviation is not 1. We need to standardize the distribution so we can treat it like the ones from last section. So we will convert every single data value or every single we will convert our mean and standard deviations into the z-scores using this z-score formula. Z-score formula is z equals data value minus the mean divided by standard deviation. Okay, in this section, we will deal with two kinds of problems. The first kind of problem is the ones we're looking for area using the z-scores. First kind of problems will be the ones where we're looking at the area or probability using the z-score. You will have to convert data value into z-scores and then find the corresponding areas. Okay, in the second kind of problems, we will be given the area or probability and we'll have to find the data value. In order for us to find the data value, we will first find the z-score and then using the z-score formula, we will be looking for the data value. Okay, there's a couple of examples done for you. I want to give you a couple of minutes to read these problems, and I'm not going to discuss these. They're already done in the notes for you, but I'm going to move on to the ones where the examples that are not done. Okay, so I'm on page 186 now, and I'm going to look at the examples that are not done in the supplement book. So here's example number 5 on page 186. The weights of adult male beagles are normally distributed with the mean of 25. So you can see the mean is not 0, mean is 25 pounds, and the standard deviation is 3 pounds. A beagle is randomly selected. Find the probability that the beagle's weight is less than 24 pounds. Okay, so for part A, we're looking for the probability of selecting a beagle whose weight is less than 24 pounds. So what I need to do is I need to convert the 24 pounds, the data value, into the z-score using the z-score formula, which is x minus mu over sigma. That is 24 is my data value. So I need to find the corresponding z-score for 24. One thing I already know that this is going to be a negative z-score because the average is 25 and this one is below the average. So my z-score is going to be negative. So data value minus the mean divided by standard deviation, 24 minus 25 over 3 comes out to be negative 0.3333. We want to round to 2 decimal places, so negative 0.33. That's all we're going to take. Okay, now we want to find the beagle with the weight less than 24. That means we want the probability of z-score less than negative 0.33. So we converted the weight into the corresponding z-score, and we're looking for the area to the left because it says less than that. And where is the negative 0.33? I'm just estimating it will be right to the left of 0. So this is the area I'm looking for, and we're going to go read the z-score table and find out negative 0.33 in the z-score table and negative 0.33. So negative 0.33 is what I'm looking for, and we will find the corresponding area. So let's look at the table. Negative 0.3 looks like 0.37. Is that right? There we go. Negative 0.33 looks like 0.3707. Is that correct? 0.3707. Okay. check with the calculator. So area to the left of, you can also use a normal CD on your calculator. So I'm looking for area to the left of negative. So I'm going to say the lower is -5, the upper is negative 0.33. Negative 0.33, and that turns out to be 0.3706, 0.3706, or 0.3707. 0.3707 if we round to 4 decimal places. So 0.3707, 0.3707. So there's about 37% chances that if I randomly select a beagle from this population, its weight will be less than 24 pounds. Okay, that's how we interpret the answers. Part B, the beagle's weight is between 23 and 26 pounds. So now we're looking for the weight between 26 pounds and 23 pounds. So again, we need to go ahead and convert both 23 and 26 into the z-scores and find out the probability or the area in between those two z-scores. So z-score for 23 would be 23 minus 25 over 3, and that turns out to be negative 0.67. Z-score for 26, 26 minus 25 over 3, that comes out to be 0.33. So we're looking for the probability. Notice I'm changing from weight to the z-scores, negative 0.67, less than z, less than 0.33. Okay, so go ahead and draw the curve and see what we're looking for. Negative 0.67 is approximately here, and 0.33 would be approximately here. It's going to be a positive z-score. We're looking for area in the middle, area in between. Let us find the area in between. We practiced a lot reading the z-score table in the last chapter, last section. So watch that video again. We're going to have to find both the areas, area to the left of 0.33 and area to the left of negative 0.67, and subtract those areas. That's what we would end up doing. Or if you're using a calculator, we would put lower bound as negative 0.67 and the upper bound as 0.33. And that's going to leave us with 0.3778, 0.3778 or 0.3779. So that turns out to be 0.3779. And if you're using StatCrunch, your answers may be slightly different because that would give you more decimal places, more accurate answer. These are rounded to the 4 decimal places. Okay. And that is going to be about 37 or about 38% chances that if you randomly select a beagle, its weight would fall between 23 pounds and 26 pounds. That's how we would interpret this solution. Okay, next one. What's the probability the beagle's weight is more than 29 pounds? We can see that 29 pounds is more than the average. So when I find the z-score for 29 pounds, this is going to be 29 minus 25 divided by 3, and that is 1.33. So probability of z greater than 1.33. Again, I'm going to go ahead and draw my curve. 1.33 is approximately here. And now we want to find out this area. Remember, my table does not give me area to the right. It actually gives me area to the left. So I first need to find out the area to the right of 1.33. Let's see, where is 1.33? It's positive. 1.3. It's 0.9082, and I have to subtract it from 1 because this is all the 1 minus 0.9082. That turns out to be 0.9082. Okay, let's see. That turns out to be 0.0918. That's 0.0918. So approximately 9% chances, so very low, 9% chances that you randomly select a beagle and its weight would be more than 29 pounds. Okay, always interpret your answers. It's very, very important to interpret your answers. Okay, number 6. The test scores for the exam in statistics class have a mean of 78 points. So we say it's not a standard normal distribution. It's a normal distribution because my mean is not 0 and my standard deviation is not 1. A student is randomly selected. Assuming that the scores are normally distributed, find the probability that the score is more than 95. Okay, so first of all, for part A, we want to find out the probability of a score. I'm just using S for score. You could use X or any other variable. Score of more than 95, we need to find the z-score for 95. So z-score for 95 would be the data value minus the mean divided by standard deviation. That turns out to be 1.89. What is the probability or the area to the right of 1.89? We're talking about more than. So 1.89 is approximately here, and we want the area to the right of it. So if you're reading the table doesn't give you area to the right. Table actually gives you area to the left. So let's go to our table and look for 1.89, 1.8, and is it 0.9707, 0.9707, and we have to do 1 minus 0.9707 to find out area to the right, because this actually gives you area to the left. The table gives you area to the left, so 0.9707 was area to the left. 0.9707 was the area to left, and we want area to the right, so we would have to do 1 minus, and that turns out to be 0.0295, 0.0295, 0.029, actually 0.0293. 0.0293. Okay. All right, next problem, part B. We want to find out the probability of selecting somebody whose score is less than 30. Well, I can see 30 is a very low score. First of all, I'm going to find the z-score for 30. So z-score would be 30 minus 78 divided by 9. That turns out to be negative 5.33. Negative 5.33. Again, if you use StatCrunch, your answer may be slightly different, or if you use a calculator, your answer will be slightly different. From the table, your answers are rounded to the 4 decimal places. Okay. In another video, I'm going to show you how to use StatCrunch to find normal probabilities. But I also want you to learn how to use the tables, how to read the tables, z-score tables. Okay, negative 5.33. So we want to find the probability or the area to the left of negative 5.33. Okay, let's go ahead and read our table. And on the very bottom, it says, somewhere I read, I thought it says somewhere, not here, but any z-scores, we can see our z-scores are only up to negative 3.49, and we have 0.002 area to its left, so very, very, very small, and we are far away from the mean in this case. So I'm gonna say there's approximately 0 probability or 0% chances of selecting somebody with the score of below 30. Let's look at part C now. Part C is we are looking for the score between 80 and 90. What's the probability of selecting somebody whose score is between 80 and 90? So their score lies between 90 and 80. We have to find the z-scores for both 80 and 90. And the z-score turns out to be, so we'd have to do 80 minus 78 over 9. That is 0.22. And 90 minus 78 over 9, that turns out to be 1.33. So we're looking for the area that lies between the z-scores of 0.22 and 1.33. Let's go ahead and draw the curve and mark where 0.22 is. 0.22 is here, and 1.33 is approximately here. And you go ahead and shade this. Again, you can use a calculator, or you can find both the areas and subtract them. Find the area to the left of 1.33 and area to the right of 0.22. This is approximating. Okay, so your answer can be a little different from what you get your calculator. What you get from the table is going to be close to what you get from the calculator, but the calculator answer is more accurate. Okay, so if you're planning to use a calculator, Casio 991 Class Whiz calculator, you would press menu number 7 and then number 2 for normal CD. For your lower bound, you can put 0.22. For your upper bound, you can put 1.33, and it's going to give you the area in between, which is 0.3211, and that's the area in the middle of, it would be 1 2 if you round to 4 decimal places, because I have 7 as the next digit. 0.3212. So 32% chances, 32% probability of randomly selecting somebody whose score lies between 80 and 90 is 32%. Okay, now let's look at part D. Part D says probability of, if there's 70 students in the class, how many will receive score between 90 and 95 points. So let's first find out what's the probability of randomly selecting somebody whose score is between 90 and 95. Let's go ahead and find the z-score for 90 and 95. It turns out to be 1.33 and 1.88, and we want the area in the middle of 1.33 and 1.88. Okay, and that turns out to be 1.33, 1.88, 0.06171. So this 0.06171 or 0.06171. Now that's about 6% chances that you randomly select somebody whose score lies between 90 and 95. Now it says there's 70 students in the class. So out of 70 students, how many of them will have a score between, out of 70 students, so we need to find out about 6.1% of 70. What is 6.1% of 70? How do you find percent of a number? So you would multiply 0.06171 if you want to be more accurate with 70, and that's how many people would have 0.06171 times 70, and 4.31. So I get approximately 4.31. Because we're talking about students, number of people, we cannot have fraction people. I would approximate around to the nearest higher number, round up because it's number of people, about 5 people. Okay, about 5 students. So out of 70 students, about 5 students will have, about 5 students will score between, about 5 students will score between 90 and 95. Okay, and that was it for this problem. And now we're going to look at page 189. The next problem we are going to be doing will be 189. This number 7 is very similar. Go ahead and give it a try on your own. I'm going to move on to problem number 8. The weight of men are normally distributed with a mean of 172 pounds and a standard deviation of 29 pounds. So we're given the mean mu here. The mean is mu and the standard deviation is 29 here. What weight separates the lightest 99.5% of the men from heaviest 0.5%? Okay, where are the lightest 99.7% of men? The lightest 99.7% of the men are, where are they? So this is where we have the lightest 99.5%, and this is where we have the heaviest, because average is in the middle, and these are the lightest 99.5% of the men. So I'm going to have to think about area. 99.5% means how much area is here. Whenever you're changing percent to decimal, you move the decimal 2 places to the right. So 0.9950. And how much area do we have here? We have 0.005. Okay, so we want to find out the z-score. So first of all, I want to find the z-score that has 0.9950 area to its left. Okay, 0.9950 area to its left. So that is the area 0.9950. We're going to look for it in the body of the table, not on the first column and the top row. Okay, 0.9950, it's going to be a positive z-score. And let's see, where's 0.9950? Again, I can see 0.99. No, it's 0.995. Let's see, 0.9950. Yeah, 0.9950. 0.9970, I see 0.995. Okay, here we go. So 0.9949 and 0.9951 are on my table, but I don't have the exact 0.9950, but I can clearly see it lies between 2.57 and 2.58, and I can find their average, and I can say 2.57 plus 2.58 divided by 2. We can do that, 2.57 plus 2.58 divided by 2, and that's going to give us 2.575, and that would be our z-score. So this z-score here is 2.575, okay, because I didn't have exact number 0.9950. Now that is my z-score. So now we're going to have to use, we actually want to find out the weight, not the z-score, but what is that weight. So we're going to use the z-score formula, which says the data value minus the mean divided by standard deviation is the z-score. So z-score is 2.575. We don't know the data value, we're looking for it. Minus the mean is 172, standard deviation is 29. To solve it, first of all, I'm going to do 2.575 times 29, and that would be x minus 172, and then I would add 172 to both sides, and that's going to leave me with my data value x. And in this case, the x turns out to be, when I simplify, 246.8 pounds. So this is the weight that separates the lightest 99.5% of men from the heaviest 0.5% of men. Okay. Part B, find P15, the weight that separates the bottom 15% from top 85%. Okay, where is the bottom 15%? It's always important to draw your curve, not a straight line. All right, bottom 15%. So I know in the middle, this is my separating 50%, top 50% and the bottom 50%. But we were talking about bottom 15% that would separate the top 85%. So bottom 15%, 15% means how much area is to the left. That would be 15% area to the left. And I don't have 4 decimal places. I can always add a 0, 0. And I can clearly see that this is going to be a negative z-score. Why is it going to be a negative z-score? Because this is way below my average. So I'm going to find out 0.1500 in the z-score table and get the z-score from there. So 0.1500, let me clear the table really quick. 0.1500, and let's see, I see 0.12 here, 0.14, 0.1587. Okay, so it looks like 0.1500 is somewhere here. Which one is closer to 0.1500? Is it 0.1492 or is it 0.1515? Looks like this one is closer. So if you're just using the table, you're gonna have to go with the one that's closer. But if you're using a calculator, then you would be able to find the exact value. So I'm gonna go with negative 1.04, okay, negative 1.04, because that's closer. So my z-score is negative 1.04, sorry, negative 1.04, and I'm looking for the weight, not the z-score. So I have to find the actual weight by using the z-score formula, x minus mu over sigma. And what is the z here? Negative 1.04, x minus the mu is 172, divided by standard deviation, which is 29. Let's go ahead and solve it. The first step would be to multiply 29 on both sides, and that would be x minus 172. And the next step would be to isolate the x. I would add 172 to both sides, and that is going to turn out to be, let's go ahead and use a calculator, 141.8 pounds. So this is going to be 141.8 pounds to 141.8 pounds is my z-score, is my weight, actually not my z-score, it's my weight that separates the bottom 15% from the top 85%. Okay, and I think I wanted to say round to 1 decimal places. It doesn't say round ton. That looks like a typo. Next problem, find Q3, the weight separating top 25% from others. Okay, the top 25%, I already know that top 25% is probably here. So top 25% means 25% area to the right. 25% is same thing as 0.2500. If it's got 25% area to the right, how much area would I have to the left? That would be 0.7500. Why am I thinking about area to the left? Because my table does not understand area to the right. It only understands area to the left. So I'm going to follow with the area to the left. So let's go ahead and look for 0.7500. 0.7500 in the body of the table. I see 0.77, 7517, and 7486. It looks like this one is closer to 0.7500, so 0.67. Again, if you use a calculator, you will get a better answer. You will get a more accurate answer. But if you are 0.677, actually, if you round to the 2 decimal places, your calculator might give you 0.68. If you were to use a calculator for it, you would be using, again, I'm talking about ClassWiz KCO 991EX calculator. You will go to menu and press number 7, and then number 3 is inverse normal, and put 0.7500 in the area. And that leaves me with 0.6744. So 0.67 is what I ended up with. Now, we don't want the z-score. We found the z-score, but we want to find out the weight, which turns out to be the z-score formula is data value minus the mean divided by standard deviation. So 0.67 equals x minus 172 over 29. So 0.67, let's go back to the regular calculator mode. 0.67 times 29, and that is, and we're going to add 172 to it, comes out to be 191.43 pounds. So 191.4 pounds. That means the weight that separates top 25% from others is 191.4 pounds. Okay, so this weight has 75% of the men weigh below this weight, and 25% of the men weigh above this weight. Okay, let's look at one more example of the normal distribution. These problems are a bit involved. You might have to watch the video one more time. Use all your resources. So normal distribution, another problem. This one is on page number 190. If IQ is normally distributed, it's telling me IQs are normally distributed, and the mean of IQ is 100 and the standard deviation is 15. Okay, so I know the mean, I know the standard deviation. Part A says calculate the probability of finding a genius whose IQ is greater than 130. Okay, so I want to find out probability of randomly selecting a person whose IQ is greater than 130. First thing, I need to convert 130 into the z-score, which turns out to be 130 minus 100 over 15, which is 30 over 15. My 30s look like 80s. Let me do a better job at it. 130 minus 100 divided by 15 turns out to be 30 over 15, which is 2. So probability of z greater than 2.00, instead of writing 2, I'm writing 2.00 because my table has 2 decimal places. We usually round the z-score to 2 decimal places. But again, if you're using technology, your answer will be more accurate and your z-score will not be just 2 decimal places. It could be as many decimal places as your calculator or the computer software gives you. So the probability of z greater than 2.00, I'm estimating the z-score 2.00 is somewhere here. It's positive z-score, and if we're looking for the area to its right, area to the right, my table does not give me area to the right. Table actually gives me area to the left. So I'm going to look for 2.00, and this is the area to the left. If this is the area to the left, how do I find area to the right? I can do 1 minus this number, okay? 1 minus 0.9772, that would give me 1 minus 0.9772, comes out to be 1 minus 0.9772. 0.0228, so 0.0228 is what I got. So about 2% chances or 2.2% chances, 2.3% chances of randomly selecting an individual whose IQ will be greater than 130. Okay, now we have part B. Part B is asking for calculate the probability of average intelligence between 90 and 110. What is the probability that you randomly select somebody and their IQ lies between 90 and 110? That turns out to be probability of z-score. Let's go ahead and find the z-scores for 90 and 110 both. For 110, the z-score would be 0.67, negative 0.67. So we want the area in between these two z-scores, negative 0.67 and positive 0.67. This will be really close to 0. So we can find both the areas from the table and then subtract them, or we can use the calculator. In the calculator, I do use menu and then number 7, and then we want to use normal CD, which is number 2. My lower bound is negative 0.67. My I put 1.67, negative 0.67. My upper bound is positive 0.67, and I'm going to leave the mean and standard deviation alone. It turns out to be 0.4971. 0.4971 is the area in between these two z-scores. Again, if you're using the calculator or you're using the StatCrunch or you're using the tables, your answer can be slightly off, but they can still be correct, okay? Still 49% chances of finding somebody whose IQ lies between 90 and 110. Now we have part C. For part C, we are looking for probability of above intelligence, finding somebody whose IQ is between 110 and 120. Same thing, IQ lies between 120 and 110. Okay, 110 and 120. Again, for MyMathLab, if your answer from the table, it should be acceptable answer from the table, but if it marks it wrong, use the StatCrunch or use the calculator to get more accurate, closer answer. Okay, first thing we need to find the z-score for 110, comes out to be 0.67. We just found it in the previous problem. And we also want to find the z-score for 120. That would be again 120 minus 100 divided by 15, and that turns out to be 1.33. Okay, so we want to find out the probability or the area in between 1.33 and 0.67. So approximately 0.67 is here, and I'm just doing by estimate. 1.33 is here. 1.33. Okay, and that turns out to be, let's see. Again, you can use a calculator or you can find both the areas from the table and subtract. I'm going to go ahead and use the calculator, plug in the lower bound, the upper bound, and I'll have the area in the middle. The lower bound will be 0.67 here. Upper bound will be 1.33. 1.33. and that is going to leave me with 0.1596. If I use, let's see what happens if I use the table, and what answer do I get from the table. Area to the left of 1.33, 1.33 is 0.9082, so 0.9082. Area to the left of 0.67, 0.6, that would be 0.7486, 0.7486. And let's see, what does that turn out to be. We get 0.9082 minus 0.7486, and that turns out to be not, no, I did not put it in correctly. 0.9082 minus 0.7486. That turns out to be 0.1596. Okay, 0.1596. This is the area to, this is going to be the area in the middle. 0.1596. 0.1596. 0.1596. 0.1596. Okay, so that's about 15% chances that you randomly select somebody and their IQ score would lie between 110 and 120. 15% is a small probability. Let's look at part D now. What is part D in this problem? There's lots of parts in this problem. Calculate the probability of somebody's IQ being less than 90. So what is the probability that you randomly select somebody and their IQ is less than 90? So let's go ahead and find the z-score for 90. We found it in the previous part. It was negative 0.67. What is the area to the left of negative 0.67? So negative 0.67 is negative 0.67 is 0.2514. Negative 0.67, it is 0.2514. 0.2514. Area to the left, that's all we were looking for, 0.2514. So 0.2514. Again, I got this from the table. If you use the calculator, your answer will be slightly different. They both should be acceptable to MyMathLab. Okay, pretty close. So about 25% chances that you randomly select somebody and their IQ will be less than 90 here. For part E, calculate the 60th percentile of IQ. 60th percentile means we're looking for P60, or we're looking for the one that has 60% of the values below, right? 60% of the values below means the area to the left is 60%, which can be represented as 0.6000. So how do we find the z-score that has 0.6000 area to the left? Well, we can use the calculator inverse normal, or we can look for 0.6000 in the body of the table. So in the body of the table, we can find out 0.6000 and see which one is the closest. 0.6000 looks like this one. Looks like this is the closest, which is 0.25, I believe. 0.25, yeah. So my z-score turns out to be 0.25. 0.25 is the z-score that has 60% area to the left. Now we don't want to find the z-score, we actually want to find out the data value. So I'm gonna go ahead and find out the data value by using the z-score chart, x minus mu over sigma. So 0.25 equals x minus 100 over 15. And when you solve it, we would be doing 15 times 0.25, and whatever we get, we add 100 to it. So that turns out to be 104. So approximately 104 is the z-104 is the IQ that separates bottom 60% of the people from top 40%. Okay, for part F, we're looking for the 99th percentile. What is the IQ score? 99% of the people have the IQ below that number. So 99th percentile means it has 99% area to the left, 0.900 area to the left. Now we are looking for the z-score that has 0.900 to the left. We can look in the body of the table. 0.900 looks like 0.99. This one looks like the closest. So 2.33 is the one that is closest. 2.33 is closest. Okay, this table is pretty long. 2.33 is the closest. 2.33 is the z-score. So 2.33 is the z-score. Again, am I looking for the z-score? Not really. I am interested in finding the data value. So I'm going to plug into the z-score formula, and then I'm going to solve for x, which is 2.33 times 15 plus 100. That would be my x. And that x in this case comes out to be 156. So 156 is the IQ for which 99% of the people have IQ below that. And then we will look at part G now. For part G, we have find the IQ score separating the top 10% from the others. Okay, the top 10% or the bottom 90% is the same spot. That means it's got the 10% area to its right. If it's got 10% area to the right, it's got 90% area to the left. So our job is to find the z-score that has 90% area to the left. So find the z-score that has 90% area to its left. The same z-score will have 10% area to the right. So you can use a calculator, you can use inverse normal on the calculator, or you can go ahead and read the table, find out 0.9000 in the table and find out what the z-score is. Let's take a look. Let me clear the table really quick. And we're looking for 0.900. Somewhere here. There we go. So I can see that these two values are close to 0.900, but this one is closer as compared to the other one. So I'm going to go with 1.28. Okay, 1.28. 8 is all the way on the top. If you move this table, you all have this table at the back of your supplement. So take a look at that table. Okay, 1.28. Right, back to the notes. 1.28 is that z-score. So now I'm going to find the data value by doing x minus 100 over 15. X comes out to be 120. So that z-score, that IQ that separates top 10% from the others is 120. 120 separates the top 10% of the people from the bottom 90% of the people. Okay, and I'm going to leave the last part H for you to try. We're looking for the IQ separating bottom 20%. So bottom 20% would be same as top 80%, and it would have 0.200 area to its left, and it's going to be approximately 113. Give it a try. Seek help if you get stuck.